Hi guys, and in this video we're going to look at Unit 2 in Independent Task 5. So same as last time, we removed the topic lists. So question 1 was a probability question. Question 2 was hypothesis testing. Question 3 was a distance time graph, and so not a velocity one, but a distance time graph. And question 4 was pulleys, so forces. And the last one was lifts. Okay, so same as for Unit 1, we removed them because part of your exam is the skill of figuring out what the topic is so you can apply the correct knowledge. Okay, so if you figured out what they were, excellent. But apart from that, let's have a look. So let's also remind you that of the levels of support. So if you didn't need any support, then excellent, really well done. It's a good topic, just keep it going on in the background. If you get into level 1 or 2, so looking at your books or watching the video, then you clearly need a little bit of a recap with those topics. And if you get into level 3 or level 4, if you're speaking to a friend or speaking to a teacher, then you need to make sure that you are actively working on these topics a lot, okay? So question 1, we've got quite a lot of information on this first bit. I've got B, T, and W. So figure 1 shows how 25 people, so all these numbers should have to be 25, travel to work. Their travel to work is represented by either B for bike, T for train, or W for walk. So I've got B, T, and W there, and I've just got a bit of an overlap between B and T. Write 2 of these events that are mutually exclusive. Give a reason for your answers. So to be mutually exclusive, my Venn diagrams don't overlap. So I've got 2 options here. I'm either going to say B and W, or I'm going to say T and W. So nothing overlaps with W. So part A, you can have one of 2 answers. You can have B and W as one answer, or you can have T and W. Okay, and we simply say it's because they do not overlap. Okay, they don't share anything in common, so they don't overlap. Now, part B wants me to test whether or not B and T are independent. So to be independent, if I take their 2 probabilities and times together, it should equal the intersect. So I'm going to find all those parts separately. So the probability of B is 9 out of 25 because I want all of circle B. So all of circle B is the 4 and the 5. I'm going to look at the probability of T, which for the same reason is 8 over 25, adding the 2 parts together. And I can get the probability of B and T from my Venn diagram. 5's in the overlap, so it's 5 over 25. Okay, so I'm going to test it. If I do the probability of B times the probability of T, we see what that gives me. Okay, it gives me 72 over 625, which doesn't equal my overlap, does it? It doesn't equal my intersect. Okay, and because of that reason, they are not independent. Therefore, B and T are not independent. So apart from that, part C and part D are fairly straightforward. Okay, one person is chosen random. Find the probability this person walks to work. So I'm looking at W. So it's 7 out of the 25. So the probability they walk is 7 over 25. Okay. Next one, I want the probability that they travel to work by bike and by train. So that's the overlap, which we've already done, but they've asked me for it separately. Overlap is 5 over 25. And there are all our answers there. So question 2 is quite a big one. Okay, we got hypothesis testing here, we said it was. Let's read everything first. So the records from a hospital showed that 3 out of 10 casualties. So 3 out of 10, straight away, probability must be 0.3. That's 3 over 10. Okay, who come to casualty department have a wait time of more than 30 minutes before receiving medical attention. The hospital decides to increase the staffing, and a random sample of 20 patients, so there's my N, were found that only 2 patients had to wait more than 30 minutes. Okay. Part 1, test a 5% significance level whether the extra staffing has reduced the waiting time. Okay, so the first thing I need to do is there's no variable, so I need to do my let x. Okay, so let x be, and it's always the number of, so number of patients, sorry, casualties, I should say, that's the word you use in the question. Who wait more than 30 minutes out of 20. Okay, so I've stolen the wording from the question, so I haven't reworded anything myself. X has to be binomial, N is 20, P is 0.3. Okay, and now you want me to test, so I need my H1, sorry, my H0 and my H1 at this point. The probability is currently 0.3. I decide out what my new thing, reduce the waiting time, so less than 0.3 is what we're looking for. I'm going to go with that. I've got a 10% significance level, so I'm going to do the probability. I've got only 2 patients, so I'm testing for less than, so I'm going to do less than or equal to 2. With this current distribution, gives me 0.0355, okay, which I'm going to compare it to 5%. It is less than 5%, okay, so therefore, sufficient evidence. So sufficient evidence to reject H0. Okay, so I can write another sentence now in context, so sufficient evidence to suggest the extra staffing has reduced that, that the extra staffing has reduced the waiting time. Okay, don't skip out on that last sentence, and I have again stolen it from the word in the question. So if you notice here, it says the extra staffing has reduced the waiting time. I've just stolen that bit, and I've just added my sufficient evidence to suggest at the beginning of it. Now, part 2 is really similar. It just wants me to test a 2% level whether extra staffing has reduced. So I don't need to do all the top bit. I can just go straight to comparing my probability. My probability was 0.0355. And what I'm going to do this time, I'm going to rewrite up here because it's a bit messy. I'm going to compare it to 2% this time. Okay, which is bigger than 2%. Now, if I use a 2% significance level, that is insufficient evidence to reject H0. Okay, so I'm going to have the same similar sentence again, but I'm just going to change the word sufficient to insufficient. So I'm going to say, so insufficient evidence to suggest the extra staffing has reduced the waiting time. Okay, so only 2 marks there because we've already done the hard work at the beginning. I just had to compare it to 2%, not 1%. Okay, now part 3, it wants me to find the critical region for a 5%. Okay, so what I'm looking for, okay, is I'm looking for the first one to be less than 5%. And what I mean by that is I'm testing for less than, which helps me a lot here. So 5% sig level is what I'm using. So if I look at the probability, I've already got one, probability of x being less than or equal to 2. Okay, that comes out as 0.0355, which is less than 5%. So that one works. Now, if I go up one and do less than or equal to 3, that comes out as 0.1071, okay, which is bigger than 5%. So that means that this here has to be my critical region. So therefore, critical region is x being less than or equal to 2. Okay, 3s wouldn't make me reject H0, 2 would. Now, part 4 and 5, we're talking about these type errors. We've got two types. We've got type 1 error, and we've got type 2 error. Okay, so we'll write a little bit extra about these. I'll go next to it. So for part 4, okay, I'm looking at a type 1 error. Okay, now what a type 1 error is, okay, is when we reject H0, okay, when in fact it was true. Okay, so it's a false positive. Okay, we rejected it when we shouldn't have in the first place. Now, in this case, it's fairly straightforward. Okay, if I want the probability of a type 1, okay, we know now rejecting it would be if it's less than 2. I'm simply going to do the probability that x is less than or equal to 2. So it's basically looking at my critical region. So, yeah, so I get 0.0355. Okay, that's my probability of type 1. Type 2 errors are a little bit harder to deal with. Okay, so type 2 error is the opposite. Okay, it's when I keep H0, so I say insufficient evidence to reject H0, when I should have, when H0 is false. Okay, so now what they tell me is the probability is actually 0.1. So my distribution should look something like this instead. So I'm going to use this distribution in calculating it. Okay, keeping H0 means I don't hit the critical region, so the opposite to this. Okay, the opposite to being less than or equal to is it being greater than 2. Okay, that's the two opposites. That's why it's important to know what our critical region is. So now I'm going to do that. That's 1 minus the probability of x being less than or equal to 2. Now I'm going to work this out my calculator, but I'm going to use the new distribution, not the old one. Okay, comes out as 0.3231. So quite a decently high probability of me making that type 2 error. So quite difficult type errors can be, okay, and you can see they can be easily mixed up, so we just need to be careful which one's which. Okay, number 3 then. We have a displacement time graph, or distance time graph as well. Okay, so we've got x going up the side of our displacement, we've got time going along the bottom. So we've got, make sure you read all the information, don't just look at the graph. Okay, a particle can move in a straight line on a horizontal surface. At time t, the displacement of p is at point A, which is x. So that's my variable here, and then I've got my diagram show. So in the interval of from 0 to 10, so 0 to 10 is whole graph, either the speed is 4 or it's at rest. So that means that all these gradients here have to be 4. Okay, so this would be a -4 because it's going down. Okay, meters a second. This would be a -4 because it's going down. This one would also be 4, and this one would also be 4. Okay, and then obviously our flat parts mean that it's at rest. So for part 1, show that t is 1.75. Now I'm going to work with this gradient here. Okay, the gradient of that line is -4. Okay, so I'm just going to use my change in y over my change in x. Okay, so my change in y goes from 5, okay, down, so I get -5 on the top, to 0. Okay, on the bottom, it goes, I want to know what this distance is along the bottom. Okay, so I've got 3 minus t. Now, if I solve this, okay, I'm going to have 3 minus t if I bring it up. I'm going to -4 down, so I get 5 over 4 because my negatives are going to cancel. And I get t, if I solve that again, I get t is 1.75 seconds, which is what they wanted me to show. Okay, now, if you didn't read the question, you would have missed out this last point here. Now, notice it mentions the word speed, not velocity. Remember, speed can be 4 no matter which direction you're moving in. Velocity can be positive or negative depending if you're moving in a positive direction or a negative direction. Now, state the velocity of p when, so I've got to find it for each point, when t is 2. So t is 2 must be, so if this is, I'm going to write it on now, this point here is 1.75. Okay, so 2 would be somewhere in between there, and we've already said it, so I'm going to do this for next bit, so I keep the graph in front of me. When t is 2, my velocity, so I need to have some negatives or positives, is going down, so it's minus 4 meters a second. Okay, at t is 8, that would be about here. That would be about here somewhere. It's on the positive, going up, so it's 4 meters a second. And then my final one is when it's 9, and it's still going up at this point by here, so its v is 4 meters a second. Okay, and I know they're 4s because of this idea they said at the beginning. Now, for part 3, I'm going to actually rub out some things here. Calculate the distance travelled. Okay, so I'm going to work out each distance. So it started up at 5 and it travelled down to 0. So this distance it travelled here was 5. Okay, the issue is I don't have where this one peaks and I don't have where this one peaks. So I need to work out what those two are. I'm going to do that simply using some speed, distance, time. Okay, I know this speed is 4 meters a second. I know this speed is 4 meters a second. Okay, so I'm going to use speed is distance times time. Time is 2 seconds. Okay, so that must be going down to minus 8. Okay, and it's going to go back up to 8. And we'll do the same thing here. If I go across, all the way across here. Okay, this is distance of 1. So in 1 second, it's going to go 4 meters. Okay, so I'm going to add up all my parts. So just 5 by here, it goes down 8, it goes back up 8, and then up another 4. So my total distance is going to be adding those up. So I got 5, I've got plus an 8 because that's it going down, plus another 8 coming back up to the line, and then plus another 4. If I add all those up, I get 25 meters in total. So a little bit of extra work required there. Now, part 4, you may have not seen it, but it's important you see it now because you will be seeing it. For t bigger than 0, so past this graph, the displacement is given by this equation here. So I'm going to write out the equation. Okay, now the first thing it says is calculate the value of t where t is bigger than 0 for the speed of the particle. So I need a velocity for this. Now, velocity is when I differentiate the displacement. Okay, so I get 20 minus 2t. Now I need to find out the t. Now it tells me the speed is 4. So I got to decide, do I want a negative 4 or a positive 4? Now, for this scenario, I'm only looking at t being bigger than 0. No, sorry, bigger than 10. If it's bigger than 10, this is always negative. Okay, so I'm looking at a negative. So I'm looking at 20 minus 2t is minus 4. I'm going to solve this for time. Okay, so I get 24 is 2t, so t must be 12 seconds. Okay, a bit of a hard one, especially since you may have not seen that topic yet. So I'll put a little star next to that one. Okay. If you haven't seen it yet, you will see it, don't worry. Okay, it was just a little add-on extra onto that topic. Okay, question 4 then. Got some pulleys. Straight away, I'm going to label my forces. So objects A and B are mass 2 kilograms and 5 kilograms. So this has got 2g going down, so I'll include its weight, and 5g going down here. Now it's connected by a light and extensible string, so that means tension is constant, and there's no mass in it. Passed over a smooth pulley. Initially it's had at rest, so initially U is 0, and then the system is released. So let's think logically what's going to happen. When I let go, the B is going to move down. It's the heavier one. This is going to move down, which means this is going to have to move up. Okay, if they're connected. So part A, find the magnitude of the acceleration of A and the tension in the string. Okay, so what I'm going to do is I'm going to resolve on each point. So I'm first going to look at A. So at A, I'm going to use Newton's second law. So going up, so I'm going to resolve upwards. So I've got T going up, minus 2g. I'm using F equals ma, by the way. gives me 2a. And I don't know what a is, fine. I don't know what t is, fine. Now let's look at b. I'm going to resolve downwards this time because acceleration is downwards. I'm going to do the same thing again. So I've got 5g going down, I've got tension going up, and that should be 5a. There's equation 1, there's equation 2, two unknowns. Let's use some simultaneous equations, okay? So I'm going to add them. I'm going to do number 1, add number 2. So minus 2g plus 5g is 3g. T minus t is going to get rid of it, and I get 7a. And type in my calculator. I know g is 9.8, so 3 times 9.8 and then divided by 7 gives me 4.2 meters per second squared. Okay, and then very quickly, all I'm going to do is I'm going to substitute that back into one of these equations, probably into number 1 is the easiest one for me to do, and then put 28 newtons. Okay, and all of that, not a huge amount of work for 7 marks. Okay, so if we can master that, that's a really, really positive one to take forward into the exam. Now the next bit, for part B, before the object A reaches the pulley, and 2 seconds after the system is released, the string breaks. Find the speed of A when the string breaks. Okay, so part 1. Okay, I've got some times. I know it started at rest, so U is 0. So I'm thinking about using suvat here. Okay, so I'm going to write out my suvat. Okay, I'm looking at A here, aren't I? Okay, and I'm going to take up as positive because that's the way it moves initially. So initially it's at 0. I want V. I just found the acceleration to be 4.2, and they told me it was 2 seconds. So I don't want S. So that equation is V equals U plus AT. So substitute my values in, V plus 0, and then 4.2 times 2. So my velocity when the string breaks is 8.4 meters a second. So that's going up. That's upwards. Okay, now part 2. Okay, given that A does not reach the pulley in the subsequent motion, and that A is 18.9 meters above the ground when the string breaks, determine the time taken for A to reach the ground. So the string breaks. So here's A. This is A. Okay, and it's currently moving upwards with a velocity of 8.4 meters a second. Okay, could the string break? It's not connected to anything now, so it's now going to free fall under gravity. So A equals 9.8. Okay, it's going to go up a little bit, and it's going to drop back down. Whereas this distance from the starting point is 18.9 meters. Okay, so again, I'm going to use some suvat. Okay, I want time. Now I'm going to take downwards as positive here. Okay, I'm going to do it because 9.8 is down and the distance is down. Okay, so 18.9. My U is going up originally, so it's minus 8.4. V I don't know, and I don't really want to know either. And A is 9.8. So this equation out of V is S equals UT plus a half AT squared. And I sub some values in. So I've got 18.9 is minus 8.4T plus half of A, so half of 9.8 is 4.9 T squared. And again, look, I get a quadratic form in here. So 4.9 T squared minus 8.4 T minus 18.9. And I'm going to use my calculator to solve. Okay. If I solve this, I get 3 and minus 9/7. Okay, time can't be a negative, so therefore T must be 3. Okay, so for the last question, okay, I got a lift. It's pulled upwards by a mean of a vertical cable. So let me draw my lift. There's my lift. There's my cable. Must have tension in the cable. Initially, the lift is at rest. It then accelerates until it reaches a maximum speed. The lift moves at this maximum speed for decelerating with a uniform at 3 meters per second. So decelerates means that's going to be a negative because it works downwards. The total mass of the lift and content is 360 kilograms. Calculate the tension in the string and the cable, and I got 2 parts. First part is when it's decelerating. And the second part is when it's moving at its maximum speed. So first of all, let's try and form an equation using some Newton's second law. So let me draw my forces on. 360g going down, tension's going up, and I'm going to say acceleration's going up because that's the way it's moving. Okay. If I use F equals ma and I take upwards as positive, I've got tension minus 360g is my 360a. Okay, now if you want to times by 9.8 here, that's fine. I prefer not to. So for part 1, I want it when the acceleration, when it's in decelerating. Now it's decelerating at 3, so when a is minus 3. I'm simply going to sub that in. Okay, so I've got t minus 360 g is 360 times minus 3. Okay, and I'm going to solve that for tension. Okay, and I end up with 2,448 newtons. Part 2, I'm going to use the same equation, but once it's moving its maximum speed. So at its maximum speed, you'll be careful with this. So at max speed, it has no acceleration. So a is 0. So that means the tension should just equal this force going down. Okay, my forces should be balanced at this point. I'm still moving. I'm just not accelerating or decelerating. So they have to be balanced at that point. Now, for part B, the crate on the floor of the lift has a mass of 25 kilograms. When the lift is accelerating, so going upwards, between the crate and the floor, so the reaction between the crate and the floor is 280 newtons. Calculate the magnitude of the acceleration. So if I draw a little diagram about what's going on there, I've got this crate on the floor. This crate is 25 kilograms, 25g, 25 kilograms here as well. It's got a reaction force, which should be going straight up, of 280 newtons. And it's accelerating. And I'm going to apply Newton's second law. So I'm going to take upwards as positive. So I've got 280 minus 25g is 25a. I know everything but the a, so I'm simply going to rearrange and solve it. You should have got 1.4 meters per second squared. Okay, so that's all of those questions now. So make sure again that you've made a note of any topics you need to go over and what level of support you've got to. Make sure you're utilizing that as best as you possibly can. But apart from that, okay, I will see you in the next video. Okay, guys? Thank you.